Unit 11, Lesson 3. Please make sure you have this paper in front of you. So we are going to be verifying trig identities in this lesson. We'll look at the left side and the right side of a problem, and we want to ensure, using the properties of trig functions and trig identities, that we can prove the left side equals the right side. Let's get started on the first one. I'm going to write the sine of x as the sine of x over 1. Please do the following. You can do this on your actual paper in your packet. You do not have to do it on the desk. Please write this in your packet. This is number 1. Now, I recognize that the cosecant can be rewritten as 1 over the sine. So I'm going to switch the cosecant to 1 over the sine. In proving the left side equals the right side, I do need to show all steps. So when I multiply across, I have sine of x over sine of x. Sine of x divided by sine of x is 1. 1 equals 1. We just proved the left side equals the right side. Let's look at number 2. Now, secant is on the bottom. So I'm going to come over here and I'm going to find secant. Secant can also be written as 1 over the cosine, but secant's on the bottom. So when I rewrite secant and I bring it to the top, instead of writing secant, it will become cosecant. I want to show that again. When secant is on the bottom, and if I move it up to the top, it would be the reciprocal of it. What is the reciprocal of secant? Cosecant. So I'm going to write this up top as cosecant of x times 1 plus the cosecant of x minus the cotangent of x. This is number 2. Please make sure you're writing this down. Did I say the wrong word? Oh, so sorry. I wrote down cosine though. Thank you for correcting that. Okay, now I'm going to multiply and distribute. So cosine times 1 is cosine of x. And then this is cosine plus cosine of x times cosecant of x minus cotangent of x equals cosine of x. Okay, I'm going to expand the second and the third terms. Cosine is on top. Now, if I take cosecant and I write it as a denominator, that means I'm going to move it from the top to the bottom. So when I move cosecant to the bottom, it's like taking the reciprocal of it. It's the same thing I did with secant and cosine. So when cosecant gets moved to the bottom, let's figure out what is the reciprocal of cosecant. The reciprocal of cosecant is sine. So I'm going to write this on the bottom as the sine of x. Cotangent can be expanded, and cotangent is the same as cosine over sine. Now we can see we have the exact same thing. They're additive inverses. That means the same quantity but different signs. They cancel out. And I have the cosine of x equals the cosine of x. Look right now at this next one. Now I can start on the left side or I can start on the right side, but I have to stay within that column. By column I mean I'm going to show all of my, when we look at this problem, I initially made a mistake in number 3, and I am going to omit that from this video, but I see sine squared plus cosine squared equals 1. That's the most common one. And so what I'm going to do over here is I'm going to change this. I recognize right now that we have a sine on the right-hand side. So I want to change the cosine. So instead of doing this, this was going to prepare me to translate the right side into equaling the left-hand side. I'm going to do this exact same thing. I'm going to take the most common trig identity, which is sine squared x plus cosine squared x equals 1. You will need to have that memorized. And I'm going to replace cosine squared x. That means I'm going to take the sine, I'm going to move it to the right-hand side. So cosine squared x equals 1 minus sine squared x. Many of you may think, like, how do I know whether I want to replace the cosine or the sine? I know that I want my final answer to look like the right-hand side, so it's going to contain sine. That means I want to remove the cosine. So I'm going to come up here, and I'm going to change this cosine into 1 minus the sine squared x minus the sine squared x. On the right-hand side, let's combine like terms. I have 3 terms. A negative 1 sine squared x minus a 1 sine squared x gives you negative 2 sine squared x. And that is much simpler than the way I originally made notes. Now the left side equals the right. I want to rewrite this in such a way that the left side equals the right side. So what I first recognize, and I know that everyone in here, I feel confident, you understand that the correlation between tangent and cotangent, right, that they're reciprocals, just like secant and cosine are reciprocals, and cosecant and sine are reciprocals. Right away, I see the connection here. These are reciprocals. So if I take this and I move it to the bottom, how would I have to rewrite it? So look at this. If I rewrite secant, secant is the same as 1 over cosine. So I'm going to write this as the cosine of x. Now, let's rewrite secant as 1 over the cosine of x. So when I multiply, I have cosine of x over cosine of x. Remember, for your test, you have to show all of your work because you are verifying what your thought process is in this. So I can't assume you know. So this would be 1 minus the cosine squared x. And by the way, this should have been a square. And what is 1 minus cosine squared x? Well, we can already see 1 minus cosine squared x. When I take this cosine squared and I move it to the opposite side, 1 minus cosine squared x is equal to sine squared. This is equivalent to sine squared. And now I have sine squared equals, let me move this up, sine squared equals sine squared. The left side is equaling to the Let's take a look. I think 5 is probably the most complicated out of 1 through 6. So the first thing I'm going to do is I recognize that none of these functions have a square. And so what I'm going to do is I'm going to multiply the top and the bottom by the conjugate of the denominator. That's the first thing I'm going to do. And because I know I need a lot of space, I'm going to try to write much smaller than normal. So you may be thinking, what is the conjugate? Conjugate means we take the denominator, in this case, conjugate of the denominator. We write down the denominator as we see it, and then we go back and whatever symbol was in between the two terms in the denominator, we're going to change it. So in this case, they're both going to be positive. The next thing I will do is I will go ahead and I will FOIL this. Now, if you don't know this fact, please look up here. This will save you time. When you have the exact same quantity, they both have a 1 in front, they both have a sign in the back, one's positive, one's negative. When you go through and you FOIL, I'll do the long steps, but I want you to recognize you are able every single time when they're exactly the same except for the sign in between, you only have to do the front and the last. So let me do it the long way. The F is for the front, O is for the outside, we get a positive sine of x. I is for the inside, we get a negative sine of x. L is for the last, a negative times a positive is a negative, and we have 2 signs. So when you have the exact same thing, you only have to do the front and the last because the O and the I, the outside and the inside will cancel every single time because they're additive inverses. So in the denominator, I have 1 minus the sine squared x. I finally have a function that's squared. Go back right now to the paper you've been asked to have out and look over here in our identities. What is, turn to your partner, what is 1 subtract sine squared x? What is 1 subtract? So you're going to have to rewrite this. 1 subtract sine squared x is cosine squared. So I'm already going to change this into cosine squared x. I know in the denominator, I'm going to grab another piece of paper here because I'm going to need more space. I know the denominator has already been rewritten as cosine squared x. So I'm going to bring this over here. I know my denominator is cosine squared x. Now I'm going to use this extra space and I'm going to take my time and I am going to, and this is going to take a little space, maybe I'll do it on a separate piece of paper. I'm going to FOIL these. I cannot use the shortcut because they're not exactly the same. I'm actually going to use this piece of paper over here. So we have the cosecant of x minus 1 times 1 plus the sine of x. And I'm going to FOIL this. Rosa, please sit over here so you have a partner for the next activity. Okay, multiplying the fronts, I have cosecant of x. Multiplying the outsides, I have cosecant x sine x. Multiplying the insides, I have minus 1. And multiplying the last, I have minus the sine of x. Now I want to make sure that I did this correctly. That's correct, correct, and correct. What is the relationship between sine and cosine? Take this back up if you forgot. What is the relationship between sine and cosine? They are what? What is the relationship between sine and cosine? They are reciprocals of one another. So I can rewrite this cosine. Cosecant, I'm saying it wrong every time, aren't I? Oh, I can rewrite this cosecant as 1 over the sine. This is 1 over the sine. I'm writing it correctly and I'm saying the wrong term. Thank you, Fabian. cosecant. Cosecant, Miss Bradley. Cosecant is 1 over sine. Sine is sine over 1. When I multiply, I get sine over sine, which is the same as 1. So right now, I'm going to slow it down so I say the term correctly. Cosecant of x plus 1, this area is equivalent to 1, minus 1 minus the sine of x. I want to see what you can do in combining these. I'm going to press pause, and I'm going to give you 30 seconds with you. Continue to correct me if I say the wrong terms. Apparently, I'm writing them down right, and I'm saying cosine instead of cosecant. All right, so these are additive inverses. So this is all in the numerator. So I have this, and I have this, and I have to figure out, like, how do I put these together? So I have the cosecant of x minus the sine of x, and we know in the denominator we have cosine squared. Now, what do we want this to equal in the end? We want it to equal just the cosine of x. Am I correct? Yes, kiddos? Okay, so let's figure out what we can do. Well, first of all, I need to figure out how to put these together. So I know the cosecant of x is 1 over the sine of x, and this is the sine of x over 1. I'm going to use the butterfly method to combine the numerators. So how am I going to do that? Remember, the butterfly method says start with this diagonal going from the left down to the right, and I multiply. So 1 times 1 is 1. I drop down the symbol, and then I multiply the diagonal that goes from right down to left. So sine times sine is sine squared. Now, what a lot of students forget is in the denominator, you have to multiply the two denominators. 1 times the sine of x is simply the sine of x. By the way, anytime I see a square of a function, I immediately, if you have not memorized them, think I need to take that cheat sheet. What is 1 subtract? So this is all the numerator, by the way. We are combining the numerator right now. What is 1 subtract sine squared? 1 subtract sine squared is cosine squared. So this area of the numerator is cosine squared. So I have cosine squared x over the sine of x. This is all the numerator. So I'm going to come up here and write cosine squared x over the sine of x. Now, I personally think that most students understand this best by taking this portion. This is all the left-hand side. The right-hand side is simply the cosecant, I caught myself, is simply the cosecant of x. I'm going to write this out horizontally. So I'm going to write this out and switch here. This is the left-hand side. It is cosine squared x divided by sine of x. And I want to divide this by the cosine squared x. And we want all of that to equal the cosecant of x. Now, when we divide fractions, we turn division into multiplying. And we flip the second fraction. And now is the obvious. This is the easiest part of the lesson. We know that when we're multiplying fractions, we have the same quantity on the top as we have on the bottom. They don't just disappear. They are going to simplify into 1. Now we have 1 times 1 is 1. And we have sine times 1 is the sine of x. And although they're not exactly the same, hopefully you recognize that another way to write 1 over the sine is with the cosecant. So this is the, bless you, this is the cosecant of x. This is number 6, lesson 3, unit 11. And this is a very simplistic problem. I'm going to distribute to end up with tangent squared x plus tangent x cotangent x. We want the left side equal the right side. Now, I recognize this relationship just like cosecant and sine and secant and cosine are reciprocal. So is tangent and cotangent. So I know that cotangent is 1 over tangent. So when I multiply, because by verifying you are showing your entire thought process, by multiplying you get tangent of x over tangent of x. And I completely understand you're like, why do I have to write all of that? Because you have to verify your thoughts. That's what you're doing. Tangent over tangent is simply 1. So this process gives us 1. And as soon as I have a tangent squared, as soon as I have any function squared, I'm going back to my identities. Please look at your identities. What is tangent squared plus 1? Tangent squared plus 1 is secant squared. Now the left side is equal to the right side.